National Electrical Code Section 410.8 requires recessed luminaires, also known as CON lights, in combustible ceilings to be listed as insulation contact rated. Section 590.3 states that all wiring methods used in garages must be approved for the location. Fire resistance rated luminaires are one of the methods approved for use in garages. It is possible that some cities have additional requirements beyond the National Electrical Code. In such cases, the final inspector may be enforcing the city's fire safety code, which could require fire resistance rated luminaires in garages. The homeowner or builder is ultimately responsible for ensuring the installation meets code requirement. The roof inspector should have ideally identified the issue during the roof inspection. However, their failure to do so does not relieve the homeowner of responsibility. The electrician is responsible for installing the lights according to the specifications provided. However, if the specifications did not call for fire resistance rated luminaires, the electrician might not be liable for the additional costs. If you encounter such a situation, firstly negotiate with the homeowner. Explain the situation clearly and request that they cover the costs of redoing the work, particularly since the change was not requested during the initial roof inspection. Secondly, consider filing a complaint with the city. If negotiations with the homeowner are unsuccessful, you could file a formal complaint with the city arguing that the roof inspector failed to properly enforce the code during their inspection. However, it is important to recognize that proving negligence or failure to enforce the code can be difficult. Thirdly, seek legal advice. If all other attempts fail, you might want to consider consulting with an attorney to assess your legal options and determine the best course of action based on the specific circumstances of your situation. It is advisable to always double-check the code requirements for specific locations, even after successfully passing a roof inspection. Communicate any potential code issues or changes to the homeowner in writing, creating a clear record of communication and agreements. Consider carrying liability insurance to protect against unexpected costs and potential liabilities that may arise during electrical work. When dealing with electrical installations, always prioritize safety and compliance with the most current electrical codes. In the event of conflicting interpretations or unclear specifications, seek clarification from the local authority having jurisdiction, also known as the AHJ, before proceeding with the installation. Electrical codes are established to protect people and property from electrical hazards, and it is crucial to adhere to these codes diligently. Fire resistance rated luminaires are specifically designed and tested to withstand exposure to fire for a defined period of time. These luminaires help to maintain the integrity of fire-rated assemblies, such as ceilings and walls, and prevent the spread of fire. The fire resistance rating is typically expressed in IRs, for example, 1 IR, 2 IRs, or 3 IRs, indicating the length of time the luminaire can effectively resist fire penetration. The selection of appropriate fire resistance rated luminaires depends on the specific requirements of the building code and the fire resistance rating of the assembly in which they are installed. Insulation contact rated luminaires, also known as IC rated luminaires, are designed to be safely installed in direct contact with thermal insulation. These luminaires are constructed with materials and designs that prevent overheating and reduce the risk of fire when surrounded by insulation. IC-rated luminaires are commonly used in ceilings and other areas where insulation is present to improve energy efficiency and maintain consistent temperatures. Non-IC-rated luminaires, on the other hand, are not designed to be in direct contact with insulation and require a specific clearance to prevent overheating. Garages are often considered hazardous locations due to the presence of flammable liquids, vapors, and the potential for vehicle impact. Therefore, electrical installations in garages must comply with specific requirements to minimize the risk of fire and electrical shock. These requirements may include the use of explosion-proof or intrinsically safe equipment in areas where flammable vapors are present, as well as the installation of ground fault circuit interrupters, also known as GFCIs, to protect against electrical shock. The authority having jurisdiction, which is typically the local building or electrical inspector, has the responsibility of enforcing electrical codes and ensuring that electrical installations comply with all applicable requirements. The AHA has the authority to interpret the code and make decisions regarding compliance issues. It is important to work closely with the AHA to obtain necessary permits, inspections, and approvals for electrical work. Electrical permits are typically required for most electrical installations, including new wiring, alterations, and repairs. The permit process involves submitting plans and specifications to the AHA for review and approval. Once the permit is issued, the electrical work can be performed, subject to periodic inspections by the AHA to ensure compliance with the code. Electrical inspections are conducted at various stages of the electrical work, including the roughing stage, which occurs before the walls and ceilings are covered, and the final inspection stage, which occurs after the electrical work is completed. The purpose of the inspections is to verify that the electrical installation is safe, compliant with the code, and properly installed. If the electrical installation fails to pass inspection, the AHA will issue a notice of violation, which specifies the deficiencies that must be corrected. The electrical contractor is responsible for correcting the deficiencies and requesting a re-inspection to verify compliance. Electrical contractors should maintain detailed records of all electrical work, including permits, inspections, and test results. These records can be valuable in demonstrating compliance with the code and resolving any disputes or claims. Electrical codes are constantly evolving to reflect new technologies, safety concerns, and industry best practices. It is important for electrical contractors to stay up to date on the latest code changes and interpretations to ensure that their work is compliant and safe. Continuing education courses, industry publications, and participation in professional organizations can help electrical contractors stay informed about code changes and advancements in electrical technology. The National Electrical Code, also known as NEC, is a widely adopted standard for electrical installations in the United States. The NEC is published by the National Fire Protection Association, also known as NFPA, and is updated every 3 years. The NEC provides comprehensive requirements for electrical wiring, equipment, and systems, and is intended to protect people and property from electrical hazards. The NEC is not a law, but it is often adopted by state and local jurisdictions as the basis for their electrical codes. In addition to the NEC, other standards and codes may apply to electrical installations depending on the specific location and type of occupancy. These standards may include the International Building Code, the International Fire Code, and standards published by organizations such as the Institute of Electrical and Electronics Engineers, also known as IEE, and the American National Standards Institute, also known as ANSI. Electrical safety is a critical concern in all electrical installations. Electrical shock, arc flash, and electrical fires are potential hazards that can cause serious injury or death. It is important to follow safe work practices, use appropriate personal protective equipment, and energize electrical circuits before working on them. Lockout-tagout procedures should be implemented to prevent accidental energization of electrical circuits during maintenance and repair work. Grounding is an essential safety measure in electrical installations. Grounding provides a low-impedance path for fault current to flow back to the source, which helps to trip circuit breakers or fuses and prevent electrical shock. Electrical equipment and enclosure should be properly grounded in accordance with the NEC. Ground fault circuit interrupters are devices that detect ground faults and quickly interrupt the flow of electricity to prevent electrical shock. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electrical shock. Arc fault circuit interrupters, also known as FSIs, are devices that detect arc faults, which are a common cause of electrical fires. FSIs are required in certain locations, such as bedrooms, to protect against electrical fires. Surge protection devices, also known as SPD, are devices that protect electrical equipment from voltage surges caused by lightning or other events. SPD should be installed at the service entrance and at sensitive electronic equipment to prevent damage from voltage surges. Electrical panels, also known as load centers or breaker boxes, are the central distribution point for electricity in a building. Electrical panels contain circuit breakers or fuses that protect individual circuits from overcurrent. Electrical panels should be properly labeled to identify the circuits that they serve. Wiring methods used in electrical installations must be appropriate for the specific application and environment. Common wiring methods include non-metallic sheet cable, also known as NM cable or Romex, metal-clad cable, also known as MC cable, electrical metallic tubing, also known as EMT, and rigid metal conduit, also known as RMC. The selection of the appropriate wiring method depends on factors such as the type of occupancy, the environmental conditions, and the mechanical protection required. Conductors used in electrical wiring must be properly sized to carry the intended current. Conductor size is based on the ampacity of the conductor, which is the maximum current that the conductor can safely carry without overheating. Conductor ampacity is affected by factors such as the type of insulation, the ambient temperature, and the number of conductors in a raceway. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overcurrent. Overcurrent can be caused by short circuits, ground faults, or overloads. The size of the overcurrent protection device must be properly coordinated with the ampacity of the conductors that it protects. Electrical equipment and appliances must be properly listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, also known as UL, or Intertech, also known as ETL. Listing and labeling indicate that the equipment has been tested and meets applicable safety standards. Electrical maintenance is essential for ensuring the continued safe and reliable operation of electrical systems. Regular maintenance should include visual inspections, testing, and cleaning of electrical equipment. Thermographic inspections can be used to detect hot spots in electrical equipment, which can indicate potential problems. Power quality is a measure of the quality of the electrical power supply. Power quality problems such as voltage sags, voltage swells, and harmonic distortion can cause equipment malfunctions and damage. Power quality monitoring can be used to identify and correct power quality problems. Energy efficiency is an important consideration in electrical installations. Energy-efficient lighting, appliances, and equipment can help to reduce energy consumption and lower electricity bills. Energy audits can be used to identify opportunities for energy savings. Renewable energy sources, such as solar power and wind power, can be used to generate electricity and reduce reliance on fossil fuels. Electrical codes and standards are constantly evolving to reflect new technologies, safety concerns, and industry best practices. It is important for electrical professionals to stay up to date on the latest code changes and interpretations to ensure that their work is compliant and safe. Continuing education courses, industry publications, and participation in professional organizations can help electrical professionals stay informed about code changes and advancements in electrical technology. Electrical safety is a shared responsibility. Electrical professionals, homeowners, and building owners all have a role to play in ensuring the safe and reliable operation of electrical systems. By following safe work practices, using appropriate equipment, and complying with electrical codes and standards, we can all help to prevent electrical accidents and protect people and property from electrical hazards. In conclusion, dealing with electrical installations requires a comprehensive understanding of electrical codes, safety practices, and the responsibilities of all parties involved. Staying informed, communicating effectively, and seeking clarification when needed are crucial for ensuring safe and compliant electrical work.